Welcome to a trigonometry final exam review. In this video, I aim to review some practice problems as well as go over some practical math concepts that you might need in this exam. So first, we're asked to solve each equation and determine all solutions and also specific solutions in 0 to 2 pi. Okay, so starting with A, 2 sine of 3x equals -1. So here we're supposed to solve for x. So dividing by 1/2, we get sine of 3x equals -1/2. So this is asking, where does sine of x equal 1/2? So what angle does sine equal 1/2? So taking a look at our unit circle, you should have this memorized by now. But just as a refresher, sine is always associated with the y term. The x term is associated with cosine. So here we can see that sine, -1/2 for sine, will be both in the third quadrant and in the fourth quadrant. And the angle would be 7 pi over 6 as well as 11 pi over 6. So our answer will be 3x equals 7 pi over 6 plus 2k pi as well as 3x 11 pi over 6 plus 2k pi. Now, solving for x, we divide by 3 on all terms. So here we divide by 3 here, and we get x is equal to 7 pi over 18 plus 1/2 k pi. Then also x equals 11 pi over 18 plus 2/3 pi k pi for any integer k. And this is our solution. Now if we were asked to find it in the 0 to 2 pi, so now to find the solution between 0 and 2 pi, we know that 2 over 3 is the same as 12 over 18 when we add to 7 pi over 18. So we can just add from 7/18, we add this right here, and we have 19 pi over 18, and we have 31 pi over 18, and if we add one more, we'll be over 36, which 36 is the same as 2 pi here. So these are the solutions for the first x. Then for the second, we have 11 pi over 18. We also have 23 pi over 18, and lastly 35 pi over 18. And these are our solutions. Okay, so moving on to B, we have 2 sine squared x minus sine 5 sine x plus 2 equals 0. So for this problem, we have to find two numbers that multiply to 4 and add up to -5. So we know that -4 and -1 work here because these two multiply to 4 and add up to -5. So factoring by grouping, we'll group these together. If we group these together and then we factor out, then we group these. Once you have these two similar terms, you know you've done it right. Finally, we solve for x for both. This will be +1/2. This will be 2. So we know that sine can never be 2. Sine can only be 1. So we'll cross that answer out, and now we solve for this one. So where is sine 1/2, positive 1/2? Well, sine 1/2 is positive both in the second quadrant and in the first quadrant. So our answer will be x equals pi over 6 plus pi k, 2k pi actually, and x equals 5 pi over 6 plus 2k pi. I wrote them differently, but it doesn't matter, same thing. And these are both solutions in 0 to 2 pi as well. So you could write this as x equals pi over 6 and 5 pi over 6 if you were asked for just those two solutions, or infinitely all solutions. Okay, so our next example, C, we have 4 sine x minus 3 cosecant x equals 0. Okay, so to start, we know that we have a cosecant and we have a sine. So let's try to get these in the same terms. So we know we can rewrite this expression as sine of x minus 3, and cosecant is just 1 over sine. So we can rewrite it like this. And now if we multiply this 3 up to here, we'll have 4 sine x minus 3 over sine x. Now, let's add these two together. However, we need common denominators. So if we multiply by sine here, sine x, so if we multiply the top and the bottom by sine x, we'll get 4 sine x squared minus 3 all over sine x equals 0. Now let's cancel this sign at the bottom by multiplying by sine, and we have to do this to this side also, but since it's 0, it'll just be 0. So now we have 4 sine squared x minus 3 equals 0. Now we know how to solve this. So solving for x, we have sine x equals, this would be add 3, and we're going to divide by 4. So this would be 3 over 4. And now we're going to have to square root to get rid of this one right here. So we get sine x equals root 3 over 2. Now, this is asking what angle does sine equals root 3 over 2? And well, we know that that's pi over 3, so, but it's positive, so this is also in quadrant 2. So we know that x will equal pi over 3 plus pi k. Also, x will equal 2 pi over 3 plus pi k. And you might ask, why pi k, not 2? Well, we took the square root here. And whenever you take the square root, it's plus or minus. That means that we'll have all solutions in all quadrants. So for this reason, we're giving plus pi k instead of 2k pi. Similarly, for the domain of 0 to 2 pi, we'll have x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Because, again, we took a square root, and when you take a square root, you'll have both positive and negative answers. So just be aware of that whenever you're taking your final exam. You don't want to screw up here because you'll be missing half of the answers. Okay, for D, we have sine squared x plus cosine x minus equals -1. So for this one, Well, let's move this one right here. And we'll have something that we're familiar with. This looks like a Pythagorean identity. So, to recall, cosine squared x plus sine squared x equals 1. So, we have a sine squared. So, let's get sine by itself, remove it here, and we get cosine 1 minus cosine squared x is equal to sine. So let's just replace that with this sine squared right here. And we'll have 1 minus cosine squared x plus cosine x plus 1 equals 0. Now if we rearrange this to make it look a little nicer, we'll have negative cosine plus cosine x plus 2 equals 0. Now we can solve this because it's a quadratic. So what two numbers gives us negative 2 and add up to 1? That is simply negative 1 and 2. So rewriting this, we'll have negative cosine squared x plus cosine 2 cosine x minus 1 cosine x plus 2 equals 0. And if we factor out by grouping, this is really sloppy. Let me just get this out the way and rewrite this. If we factor by grouping, now we factor out a cosine. A negative cosine x. We'll have cosine x equals, minus 2. And here we'll have to factor out a 1, a negative 1, to get cosine x minus 2. So always when you're factoring out by grouping, you want to have these two terms match, and that's how you know you've done it correctly. Now if we rearrange this, cosine x minus 1, and then cosine x minus 2. And we solve for x, we'll have that cosine x equals to, add 1, divide by negative 1. We'll have negative 1 here, and then here we'll simply have cosine x is equal to 2. Now, finally, we can write our answer as x equals pi, because that's where cosine is negative 1. Also, remember, cosine can't equal more than 1, so that's not an answer anymore. So plus 2k pi, and that's for all solutions, and for a solution in the interval, we'll simply have pi. That's it. Okay, so we're told to rewrite these equations using at most one trigonomic function. To start, we'll start with a, and it's 2 sine 4x times cosine of 4x. Here, it might seem like we should use a double angle identity, a sum and difference identity. However, we already are in an identity. This one looks just like the double angle formula. Looking at our formula sheet, we can see that this is the double angle formula. So we simply multiply the angle. So doing so, we'll have sine of 8x. That's it. Okay, now C, we have sine x, cosine x, secant x, and cotangent x. So our approach, let's get everything in sines and cosines. So here we'll have sine x, cosine x, 1 over cosine x, and here we'll have cosine x over sine x. What do we notice? We notice that these two cancel, and then if we multiply, and then these two cancel, and we're simply left with cosine x, and we have our solution. Okay, so E Okay, so for E, what we can start off by doing is rearranging this complex fraction. Okay, so if we keep change flip, we'll have secant theta minus cosecant theta all over 1 times the reciprocal, which is sine 2 theta over sine theta minus cosine theta. Here, we did this so we can switch this into one of our identities. So we know that the 2 angle theta for sine is this formula. So if we change this to 2 sine theta cosine theta all over sine and cosine theta. Now these we can change. Remember, these are just the reciprocal of sine and cosine. So we'll have 1 over cosine theta minus 1 over sine theta. And these are being multiplied. So now let's add these two together. And we'll have to multiply top and bottom by each denominator. For cosine, we'll multiply by sine theta, and here we'll multiply by cosine theta. Now we'll have sine theta over cosine theta sine theta minus cosine theta, if we subtract these fractions, multiplied by 2 sine theta cosine theta all over sine theta cosine theta. Now here we realize that these two will cancel, and one sine will cancel, and then another cosine will cancel, and we simply have 2 as our answer. Okay, so I'm not going to do all of the problems just so we can get through more. So let's get on to the next example. Okay, so in this next problem, we're asked to sketch the graph of each function. So a quick overview on a cosine and sine function. We have that A is the amplitude, B is the period, and to get the period you'll always have to do 2 pi over B. C is the phase shift, and D is the vertical shift. So to start, we see that A will have an amplitude of 3, here we notice that it's 4 pi times x. So we're going to take the 4 pi as b, and we'll plug that into our formula, 2 pi over b. And plugging in 4 pi, we see that pi will cancel, and then we'll be left with 1/2. So that's our period, 1/2. Okay, so now what you want to do to graph the functions like these, you want to take this, you want to take your period and divide it by 4. This way we'll get 4 even spots to graph. So if we divide it by 4, we'll get that it's 1/8. And now what you want to do is add 1/8 to 1/8. And we'll get 1/4, and then we'll get 3 over 8, and we'll finally get 1/2. So now we have 4 points that we can plug into our equation. These will be our x's, and for corresponding y, this will be 3, this will be 0, this will be -3, this will be 0. And you just plug this in as your x in the equation. Y equals 3 sine 4 pi over x. So you'll just plug it in here. Now we plot it on our graph. Since it's a sine function, we'll start at the origin, and then we'll travel up 3 units because we said the amplitude was 3. Remember, also will be -3 because it's an amplitude. And we'll plot 4 sections here. This is not going to be to scale, but 4 sections. This is why we divided by 4, and we had 1/8, and we had 1/4. We also had 3/8, and finally 1/2. The trick here was dividing by 4 so we can have 4 spots that we can graph and get our first period. So we said that if we plugged in x, 1/8 for x, we'll have 3, so we're here. And then for 1/4, we'll have 0, and then we'll have -3 here at 3 over 8, and then we're back to 0. As you can see, this was one perfect period for sine, and this is how you graph it. So here for the next example, B, we actually have a vertical shift down 3 units. So down 3 units. Here we have an amplitude of 2, up and plus and minus 2. Now B here, B is going to be pi over 2. So if we plug in to our formula, multiply by the reciprocal, pi cancels and we're left with 4. So that's our period. Now we need some x values and y values. So again, remember I said divide by 4 to get 4 equal parts in your graph. So we'll have 1, and then if we add 1, we'll have 2, 3, and 4. So those are our 4 parts. So if we plug in these x values to our function, we'll have -3, -1, -3, and -5. Now, then we must realize also that we have a phase shift. We have a phase shift of negative pi. Before we graph this, I forgot to add 0 because, well, we need to start at 0. And if we plug in 0 to our function, we'll have -5 also. So now let's plot this. Okay, so like I said, we start at -3 units. That was our vertical shift. And now our amplitude was 2. So we go up 2, which would be -1, and we go down 2 as well. And this will be -5. So at 0 we'll be at -5. At 1 we'll be at -3. I forgot to label this. So this would be 1, this would be 2, this would be 3, this would be 4, and just 5. Okay, so now at 1 we'll be at -3, and then at then at 2 we'll be at -1, and then we'll be back at 3, and then finally we'll be back at 5 when x is 4. So sketching this, remember this is our origin line, we have something like this. Again, I'm sorry for my graph, and this is how this graph would look like. Now, going back to our function, we had y equals 2 cosine pi over 2x minus pi minus 3. You might be wondering why we're starting at the bottom if the regular cosine graph starts like this. Well, this is because we shifted pi. Since we shifted pi, we actually start from the bottom. Okay, for our next example, we have if theta is an acute angle of a right triangle such that sine is 15 over 17, determine the values of the remaining trigonometric function at, and this should be theta. Okay, first we have to sketch a triangle or use the Pythagorean theorem to find the remaining sides. But first, let's identify what quadrant we're in. So if sine is positive, we know that we can be either in the first or second quadrant. So let's just keep that in mind. Okay, now let's draw a triangle to find the remaining trigonometric functions. So sine is 15, so opposite over hypotenuse. Okay, so to find the other side, I'm going to do 17 squared equals 15 squared plus b squared, where this is b solving, and we get that b is equal to 8. Okay, so now, since we know sine, let's just write it down here. 15 over 17, of course it's theta, so sine of theta, 15 over 17, cosine of theta equals adjacent over hypotenuse, so 17. Tangent is opposite over adjacent. Cotangent is just the reciprocal. Secant is the reciprocal of cosine. And cosecant is the reciprocal of sine. Now, we're asked which values would change sign if theta is between 450 and 540 degrees. Okay, so how do we go about solving? First, we have to determine where is theta in. The easiest way for me would be to subtract 360 degrees from each angle. This way, I'll get their coterminal angle, which I'm familiar with. So this would be 90, and this will be 180. And this is theta. So, since we know that this is the second quadrant, makes sense because sine is still positive there. Well, cosine is going to be negative, tangent is going to be negative, cotangent, and reciprocal of cosine, which is secant. All these will be negative. And that's what it was asking. What values would change sign? So that's how you do that problem. Okay, for our next example, we're going to be converting from rectangular equations to polar equations. Now, recall, well, r squared is equal to y squared plus x squared. Tangent theta is y over x. X is equal to r cosine theta. And y is equal to r sine theta. Using these relationships, we'll determine the polar equations. Okay, so starting off with A, we have that x squared plus y squared is equal to 4x plus 4y. Okay, so here we could clearly replace this right here with an r squared. Here we can replace 4x with r cosine theta and 4y with r sine theta. Now, we could factor and solve for r. So factoring out an r, we have 4 cosine theta plus 4 sine theta equals r squared. And now, dividing by 1r, we have r is equal to 4 cosine theta plus 4 sine theta. And that's your answer. Okay, so our next question, B, we have x plus y equals 5. So this one is pretty straightforward. We just replace them. Solving for r, we just factor out an r. And we solve for r. And you're done. Okay, for C, we have 2x squared plus 2y squared equals 3. Now here, we have the two terms squared. So we can see that we can potentially replace with r. But there is a 2 in front, so we can't do a direct substitution. So what we can do is just factor out that number, 2, and be left with just the variables here. Now we divide by 2 and substitute this with r squared. So we'll have r squared is equal to 3 over 2. And that's all you can do. Okay, for our last example, D, we have 2xy equals 1. Okay, so here, let's try to get x and y by themselves first. So we divide by 2. We'll have x times y equals 1/2. So for this example, a window is constructed in the shape of the top half of an ellipse. The window is 30 inches at its tallest point and 90 inches wide at the bottom. Determine the height of the window at a point 20 inches from the center of the base. Okay, so to start, I'm going to draw this shape in order to get a visual representation of what I have. Okay, so we're told that at its tallest point, it's 30 inches. So I'm going to take the center of the ellipse at the origin to make it easier on myself. So since this is 30, so the point would be 0, 30. Okay, and we're told that it's 90 inches wide at the bottom. This means that this would be -45, 0, and this side will be positive 45, 0. This is because the whole length will be 90 inches here. Okay, so in order to determine the height of the window at a point 20 inches from the center, which is this right here, 20 inches from the center, they want to know the height right here. Okay, in order to find that, we need the equation of an ellipse. So first, let's determine what type of equation we're going to have. Since 45 is larger than 30, because this is the highest point. So at its highest point, it's 30 inches, and at its widest, it's 90. So half of 90 is 45. So because 45 is larger than 30, we know that our ellipse is going to be something like this. It's going to be stretched horizontally. Okay, so with that information, we know that A must be under x squared. So recall that this is the equation of an ellipse in standard form with an ellipse stretched on the x-axis. If it was stretched over the y-axis, instead of having a squared under x, it would be b squared plus y squared over a, because a is always greater than b. Okay, so with this information, we can plug in points. So a, the distance from the center to the vertex, has to be 45. And then to the co-vertex, which is b, is 30. Now, plugging it into our equation, we have x squared. We square 45. This is 2025 plus y squared over b squared, which is 900, equals 1. Now we can plug in 20, this point, 20, 0, to get our y value. Okay, in solving for y, we have y is equal to 26.87 inches. So at a distance of 20 inches from the center, this window will be 26.87 inches tall. Okay, for this problem, determine a rectangular equation for the curve by eliminating the parameter. Okay, so we're asked to find the conic section given these equations. Okay, so let's begin with b. Okay, so since we have x, 2 cosine t, and we have y equals 3 sine of t. So in order to eliminate the parameter here, what we need to do is solve for just cosine and sine. So here we'll have x over 2 equals cosine t, and then y over 3 equals sine of t. Now, recall cosine theta squared plus sine squared theta equals 1. Using this information, we can do x over 2 squared plus y over 3 squared is equal to 1. Now, this substitution is valid because since cosine t is equal to x over 2, we're just substituting in the values. Okay, now we solve x squared over 4 plus y squared over 9 equals 1. So this equation should be familiar. This is an equation of an ellipse. Okay, so now we can get rid of this. So we have an ellipse that stretches over the y-axis. And this is because we have a, which is always greater than b in an ellipse, under y. And this means it will stretch on the y-axis. Okay, so now let's determine a, b, and c in order to determine the vertex, the co-vertex, the foci, and all that. Since we said this is a and this is b, a must be 3 since it's squared in the equation. b will be 2, and c is c squared equals a minus b, because a is always greater than b in an ellipse, and these are squared. Okay, so 9 minus 4 equals 5, and that's c squared, so it's square root of 5. Okay, so now we can determine the vertex and the foci. So recall that an ellipse will have a vertex on each point where it's stretched on the major axis. This is the major axis because it's the longer side, and that is the minor axis because it's the shorter axis. And the minor axis will house the co-vertices, and like I said, the major axis will house the vertices. Now the foci is always closer to the center than the vertex in an ellipse, so it'll be somewhere around here. Now, to determine the actual distance, well, we have A, B, and C. The distance from the center to a vertex is A, so this distance right here is going to be 3. The distance from a foci to the center is root 5, that's C. And then the distance from the center to a co-vertex, that's B, so B on either side. So now we can write our characteristics. The center is 0, 0. The foci, well, since this ellipse stretches over the y-axis, we're just going to be modifying the y variable. So 0, comma, plus or minus root 5, that's for each side. I'm doing plus or minus just so not. The vertices will be 0 plus or minus 3. The co-vertices will be actually modifying the x term because they're on the x-axis, plus or minus 2, 0. And the major axis is a distance of 2a, which would be 6. Minor axis is a distance of 2b, so it's length 4, and that's it. Okay, so we're asked to determine a rectangular equation for the curve by eliminating the parameter. So we have x is equal to sine squared t, and y is equal to cosine t. Okay, so using our Pythagorean identity, we know that sine squared theta plus cosine squared theta equals 1. So we can replace cosine and sine with x and y. So it would be x is already squared. Notice that x is already squared. So we just do plus y. Cosine needs to be squared, so we square y equals 1. Now we solve to get one variable on one side. Now recall that the conic section with one term squared will be a parabola. So let's solve for y to get this in a standard equation for a parabola. So we have y equals 1 minus x, and here we are not in standard form, so let's factor out a negative 1 from this side. So we'll have negative 1, positive x, minus 1 is going to be equal to y. It's going to be equal to y squared. And this is our parabola in standard form. Okay, so we don't need this anymore. Okay, so now let's determine all of the characteristics. To start, let's identify what way this parabola will open. So here's our little grid. Now we know that if we have a y squared instead of an x squared, it's going to open left or right. Now what side will it open? So we know that if p is less than 0, it will open left. Now if p was greater than 0, well, not a negative, it will open to the right. Okay, so with this information, we know that our parabola will open this way. Okay, so now let's identify the characteristics. Now, recall that here, this term right here is equal to 4p. So let's solve for p, because p, as you know, will give us the distance from the vertex to the directrix, and from the vertex to the focus. So p is really valuable here. Okay, so setting 4p equal to -1, divide by 4, we get that p is -1/4. And this makes sense because, like we said, p is negative, so we'll open to the left. Okay, so let's just put this here. Now get this out of the way. And now, the directrix, since we have y squared, we'll use the equation x equals h minus p to find the directrix. So x equals h, which h is +1, because we always flip the sign. Here this is 8 minus p. Don't forget to check your signs. And we'll get x is equal to 1.25. So our directrix will be at x equals 1.25. So I forgot to state our vertex. Our vertex is at +1, 0, because, like I said, we have a 1 here, and you just flip the sign, and we have no term here, so that is 0. Okay, so our vertex is right here. That is our vertex. Okay, so now our focus, remember, the parabola will always eat its focus, so meaning it will open towards the focus, and the directrix is always behind it. It's a distance of p from the vertex to the focus, so this is a distance of p. And now p is 1/4, -1/4. So in order to get this, we'll do 1 plus -4, 0. 1 plus -1/4 will give us 0.75, 0. So this is 0.75, 0, and that is our focus. And we have found all the characteristics of a parabola. The cables of a suspended bridge are in the shape of a parabola. The towers supporting the cables are 400 feet apart and 100 feet high. The cables are of a height of 20 feet midway between the towers. What is the height of the cable at a point of 40 feet from the center of the bridge? Okay, to start, I like to draw a picture of what the problem is talking about. So we know we have a parabola that looks something like this. It's not going to be to scale. Something roughly like this. Okay, something like this. And that we're told that each supporting beam is 100 feet high. And the distance of these two is 400. So let's take the midpoint as 0, 0. So this will be a distance of 200. So this point right here will be -200, 0. And then this one will be +200, 0. Since we're taking the midpoint as 0, 0. And then we're told that midway, right here, the cables are a height of 20 feet. And we're asked to find what height is the cable at a distance of 40 feet away from the center. So what is the height here? Okay, so with this sketch, we can construct an equation of the parabola and then plug in 40 to get our y value. So since we know that our parabola opens upwards, we'll have x being squared. So our standard form would look something like this: x minus h squared equals 4p y minus k. Okay, so that is our standard form. Now let's plug in some values to get our equation. So we know that a point on this graph will be this one right here. And this point is 200, comma 100, because it's a height of 100 and it's a distance 200 from the center. Okay, so let's plug that in to solve for P, because right now we do not have any information of a focus or a directrix to find P. So that's what we need to solve for first. Okay, so before we plug it in, we need to realize that our vertex right here is 0, comma 20, because we were told that the height was 20 at the middle. So this would be our vertex. So plugging in what we know, so we know the point 200, that'll be squared. Now for P, we don't know. Y value is 100, and our K value will be 20 because that's our vertex. And here H was 0 because it's 0 at our vertex. Okay, so solving for P, we get 40,000, and now this is 80 times 40, and this is 80 times 4, we get 320, so we divide, we'll have 125. And this value right here will equal P. Now that we know P, we can write our equation as x minus 0, so just x, squared, equals 4P. We can either write it like this, or just write 500, whichever one you like. Then, yeah, I'm going to write it equals 500, because 4 times 125 equals 500. It's just a cleaner way to write it. Y, and then our vertex is a distance of 20, so we need to write it as negative 20, because we always flip the sign. And that's our equation. Now we can get this out of the way. Now with this equation, we can find what the problem was asking, which is the height at a distance 40 from the center. So plugging in 40 to our equation and solving for y. 40 squared is 1600 divided by 500. We'll have 3.2, and now this is equal to 1 minus 20. We add 20 to each side, and we'll have our y value as 23.2 feet. So at a distance of 40 feet, our height will be 23.2 feet. And we're done.